Alright, our next example is to find the derivative with respect to x of x, y equals 8. So, hopefully you notice, this is a product. I'm multiplying x and y, so I'm going to use the product rule. So, first, x times the derivative of the second, which the derivative of y is just 1. So I have to stick a dy dx on there. So first times the derivative of the second, plus the second times the derivative of the first, which is just 1, equals the derivative of 8 is 0. So a question you might be having is, Ms. Briscoe, you have a y right here, but you don't have a dy dx. I didn't take the derivative of y. Remember, first times the derivative of the second, plus the second, didn't take the derivative of it, second times the derivative of the first. So you only stick a dy dx when you're taking the derivative of something with a y. Alright, so I am trying to isolate dy dx, so I'm going to subtract y from both sides, leaving me with x dy dx equals negative y. And I'm trying to get dy dx all by itself, so I'm going to divide by x on both sides, giving me dy dx equals negative y over x. So you can use the product rule and implicit differentiation at the same time. Ooh, whoops. Next one, the square root of x plus the cube root of y equals 5. Well, the first thing we want to do is rewrite this. So you get x to the 1/2 plus y to the 1/3 equals 5. So now we take the derivative, pull my exponent out front, subtract 1 from your exponent to get negative 1/2. The derivative of y to the 1/3 is 1/3 y, and then subtract 1 to get negative 2/3. So remember, I just took the derivative of something involving a y, so I'm going to stick a dy dx on there. And then the derivative of 5 is just 0. So this is where it gets a little tricky. First, we want to get rid of anything that doesn't have a dy dx. Trying to isolate dy dx. I'm going to subtract this business. Negative 1/2, x to the negative 1/2 from both sides. I'm left with 1/3 y to the negative 2/3. If y'all are cool with that, I'm going to send that to the denominator all in one step. So remember, if you have a negative exponent, you need to send it to the denominator to get rid of it. So this is y to the 2/3 in the denominator. dy dx equals, and the same thing over here. I'm going to send this to the denominator as well. Negative 1 over 2x to the 1/2. Okay, so I'm trying to isolate dy dx. So I would normally divide by 1 over 3y to the 2/3. When you divide by a fraction, that's the same thing as multiplying by the reciprocal. So I'm going to multiply both sides by 3y to the 2/3. Remember, this is 3 by the 2/3 over 1. So these cancel out, leaving me with dy dx equals, multiply straight across the numerator, negative 3y to the 2/3 over straight across the denominator, 2x to the 1/2. Final answer. Alright, for our last example, things are going to get a little crazy because if you notice, here, we're going to use the chain rule. Here, we're going to use the product rule. So it's going to get crazy to take the derivative of this. So, start by taking your exponent, pulling it out front. Keep the insides the same, don't touch them. Subtract 1 from your exponent. And now you're going to take the derivative of what's inside the parentheses. So the derivative of x squared is 2x. The derivative of y squared is 2y. So because you just took the derivative of something involving a y, you're going to stick a dy dx in there. Then we have product rule. So think of 100x as your first term, and think of the y as your second term. So first, 100x times the derivative of the second. Remember, the derivative of y is just 1, but I have to stick a dy dx on there. So first times the derivative of the second, plus the second times the derivative of the first, which is just 100. All right, I'm going to try to make my life easier, so I'm going to actually expand all of this out. So I'm going to first start by distributing the 6 into these parentheses to get 6x squared plus 6y squared times 2x plus 2y dy dx equals 100x dy dx plus 100y. Okay, now I'm actually over here and have to FOIL this out. So 6x squared times 2x is 12x cubed. 6x squared times 2y dy dx is 12x squared y dy dx. Then the inside terms will give me 12xy squared. And then the last terms are 12y cubed dy dx equals 100x dy dx plus 100y. Okay, so this is the part where we want to get everything that has a dy dx on the one side, everything that doesn't have a dy dx on the other side. So I'm going to keep these dy dx's, I'm going to keep these two terms on the left side. So that means I'm going to subtract 12x cubed from both sides. And I'm going to subtract 12xy squared from both sides. And it also means that I need to move this bad boy to the left side. So I'm going to subtract 100x dy dx from both sides as well. So I moved everything that has a dy dx to the left and moved everything that doesn't to the right. So this will give me 12x squared y dy dx plus 12y cubed dy dx minus 100x dy dx equals 100y minus 12x cubed minus 12xy squared. Okay, move everything with a dy dx to the left, move everything without a dy dx to the right. So now I need to factor out a dy dx from all three of these terms on the left. So I'm going to pull out a dy dx, leaving me with 12x squared y plus 12y cubed minus 100x in parentheses. And then the very last thing I need to do is divide everything by 12x squared y plus 12y cubed minus 100x. And then my very last thing is, I hope you notice that 12 and 100 are all multiples of 4. So I'm going to reduce all of those by 4. I'm going to divide out a 4 from all of them. So 100 divided by 4 is 25y minus 12 divided by 4 is 3x cubed minus 3xy squared over 3x squared y plus 3y cubed minus 25x. And whoa, mama, that is your final answer.